counting problems. In the first case, we want to see the number of ways that k tasks may be performed, and this would be the framework. Now, the advice I have for you, ladies and gentlemen, is instead of trying to memorize these frameworks, try to recall the examples we're going to use under each of these scenarios, because then you'll be able to recall the process much easier during the exam. So, for example, suppose that in order to make steel, let's just assume that there's 3 tasks that are required. So first you have to clean the raw material, then you have to heat it, and then you have to plate it. And of course, I'm making all these processes up because we just want some tasks. Now, each process or each task may be performed a number of ways. So there's 8 ways to clean the raw material, 5 ways to heat it, and 12 ways to plate it. So therefore, what is the number of ways that steel may be produced? So remember, you got these 3 stages, and each stage has the multiple ways of being performed. So how many ways, if you look at all possibilities, how many ways is it possible to have the final product? Having gone through these 3 stages, you would just multiply the number of ways that each task is performed. So task 1 8 times, task 2 5 times, and task 3 12 times. So when you multiply all that together, you get 480 different ways that the final product may be manufactured. In the second scenario, we want to count the number of ways that n objects may be placed into k labels. So once again, I mean, there's your framework. But again, I think it'll be easier for you to recall this process if you just try to sort of understand the example I'm about to show you. Suppose that the analyst is covering 10 stocks. So this would be n equaling to 10. So that's 10 objects. And the task is to categorize the 10 stocks into 3 labels. So in this case, K would be 3. And here's what the analyst is trying to achieve. She's trying to find 5 stocks that are undervalued, 2 stocks that are fairly priced, and 3 stocks that are overvalued. So that represents the 10 stocks that she's examining. And then these 3 labels are the labels, right? So undervalued, fair value, and overvalued. So therefore, to calculate the number of ways that 10 stocks may be categorized into 3 groups, so there's that framework. But here's what we do. We look at the total number of objects, and we take its factorial, so 10 factorial, divided by the number of objects for each label. And of course, we take the factorial of the number of objects. So then when you work these out, you get this number, so 2,520. So let's just interpret this. There are 2,520 ways in which 10 stocks may be categorized into these 3 groups. Because remember, every time you move one stock from one category to another, that represents a new count. So you could see how it'll add up to 2,520 possibilities. Now we have a special case. What's the special case? The special case is when there's only 2 labels, and then it's referred to as a binomial. So we're going to look at 2 specific instances of this binomial framework. In the first case, we have a binomial where the order does not matter. So if the order does not matter, this is the framework that we would use. And ladies and gentlemen, this framework here is exactly identical to this framework here. So for example, if there were only two labels, then we would only have 2 variables in the denominator, just like we have over here. And that's why I referred to this binomial count as a special case of this broader framework that we have here. Because with this framework over here, you can have multiple number of labels, but with binomial you just have 2. And again, what I'm trying to do here is by linking these two together, I'm trying to show you that it's just you're applying the same thing rather than treating these two as two separate formulas that have to be memorized. Okay, so now let's look at an example in which the order does not matter. Suppose that out of 10 potential stocks, we're asked to compute the number of 3 stock portfolios that are possible. And let me just jump ahead for a second to show you why the order does not matter. Suppose that the first portfolio has stocks A, B, and C, and the second portfolio has B, C, and A. But does the order really matter? Because both portfolios have the same 3 stocks. So whether you have a listing of, whether you've listed your stocks as ABC or whether you've listed your stocks as BCA, that's still the same portfolio. It's the same 3 stocks you have in there. So the order in which you list your stocks is not going to affect its return. And again, this demonstrates why the order does not matter in this particular scenario. So now let's elaborate on our framework. In this case, we have 2 labels. There's the label that includes the stocks, and then the other label is for the stocks that are excluded from the portfolio. Because remember, we're just looking for a 3-stock portfolio from a total of 10 stocks. So you're going to have 2 groupings. One group will include the 3 stocks you're including, and the other group will be the 7 stocks that you excluded from that particular portfolio. So therefore, what we just did here is we established all the values for this framework. So here we go. So I'm just going to restate it right there. We have a total of 10 objects, and we have 2 labels, or 2 categories, if you will. One category is the stocks that are not included. So that would be the 7 stocks not included. And then the other category is the 3 stocks that are included. And again, remember, ladies and gentlemen, you have to take their factorial, right? And when you work this out, you get 120. So to answer the question head on, there are 120 ways in which we can construct a 3-stock portfolio using 10 stocks or from a selection of 10 stocks. Now, in the second instance, we're going to look at how the framework gets modified when the order does matter. So when the order matters, all we do is, you can see the transformation here. So from this framework, we just drop the X there, and then you get this following framework. And that's it. So now let's look at an example in which the order does matter. So look, notice I'm using the same number of objects and the same number of labels or categories, namely 2. So we have 10 potential stocks, but now we're asked to calculate the number of top 3 picks that are possible. Why does that matter? Because now, when you say top 3, first place is not the same as third place. So if I can again jump ahead a little bit, in list 1, we have A as the best performer, whereas C is the third best performer. Now in list 2, we have the same 3 stocks, but now the order is different. In list 2, B is the best performer. So even though it includes the same 3 stocks, each list represents a different scenario. It represents a different count. And there it is. These are different ranks. Therefore, the order does matter. So therefore, the 2 labels again, the stock that's included in the top 3, this would be X. And then the stocks that are excluded from top 3, this would be N minus X. So continuing with our example, there's the 10 objects. And N minus X would be right there. So 10 minus 3 factorial, and therefore you would get 720. So to answer the question head on, there are 720 ways in which we can rank top 3 stocks out of a universe of 10 stocks. So now let's summarize the data. And again, you'll notice that in my examples, I kept the objects the same at 10, and the X was 3. So in the first scenario, we're looking at 3 stock portfolio, and in the second scenario, we're looking at top 3 ratings. But you'll notice that when the order did not matter, there were 120 possibilities. And you can see that by going back to that example just very quickly, even though we have two separate portfolios, it's the same portfolio. So therefore, this just represents one count. But when you see when the order matters, even though I've ranked them the same way, so A, B, C first and then B, C, A, you can see that the order does matter. So these would be different counts. So what I hope this demonstrates, just using this simple example, is when the order does matter, you're going to have a higher count. And that's exactly what we determined here.